Hi, welcome back to the Jerusalem Science Contest. This is at least my last week of lecturing, and I believe you will have 2 more lectures after this from Rabbi Weiner, but today we're going to be looking at Chapter 18 in the book, and this is the 13th lecture, The Impact of Humans on the Marine Environment. So this mostly deals with the negative effects that we have on the marine environment, this particular chapter. And in fact, what I want to concentrate on is actually found on page 415 of your book. Well, maybe it's 414 and 415. It talks about pesticides. It actually starts on 413 under the heading of persistent toxic substances. So these are materials that are not readily biodegradable, and they're materials that when they get in the environment, you expect them to be around for a long period of time. And there are a number of compounds that we know about that are not necessarily in the aquatic environment, but for instance, there was a material that was manufactured for treating ants called chloridane, and it was the best possible way of getting rid of things like carpenter ants and ants that would infest people's homes. And it was found that once you put it down on the ground, it would still be there 50 years later, maybe even 100 years later. It never goes away. So those are the kinds of materials that we talk about being really persistent, and that material is no longer used. Its use has been banned. So there are other materials that actually have found their way into the streams and the rivers and the oceans of the world, and these are materials that in some cases we should be concerned about. In other cases, in my own opinion, I think the concern is a little bit overblown, but I want to talk about that today. So I particularly want to talk about the section that says PCBs and other toxic organic chemicals. And the first of these compounds are compounds called PCBs, or polychlorinated biphenyls. And what they look like, I know a little bit about PCBs because I spent about 5 years actually working on and developing a process for destroying these materials. So the company that I work for, a company called Chemical Waste Management at the time, was interested in developing a chemical-based process in which we could treat polychlorinated biphenyls. So what are polychlorinated biphenyls? This is the biphenyl molecule. It's 2 benzene rings joined together. And the polychlorinated biphenyls are a series of compounds that can have up to 10 chlorine atoms, in which case we have pentachlorobiphenyl. There could be 9 chlorine atoms, so we could remove a chlorine atom from one of these molecules and replace it with a hydrogen. And we could do it here, or we could do it over here, or we could do it over here. That's it, because anything else, because of the symmetry of this molecule, I don't think I did that right. I think I wanted to put, I put the chlorine here, put the chlorine here. We have a single chlorine, I'm sorry. So I'm not doing this correctly. I want to have just a single hydrogen, I'm sorry. So I did that, and then the last one is this one. I probably did this already. But the point is, there's only 3 of those that you can get that have a single hydrogen in them. There's one that has no hydrogen, one that has 3 hydrogen, and then the number starts going up, and then you can get down to a compound, for instance, that has only 1 chlorine. So each of these chlorinated species is referred to as a congener. They're called congeners. And the total number of ways in which you can arrange between 1 and 10 chlorine atoms in this kind of a molecule, there are actually 209 possible PCB congeners. So when they talk about PCBs in the environment, they're referring to not any one of these things, but a whole mixture of them. And these things were sold back in the 70s or prior to that under the name of Arachlor, and they were given various designations like Arachlor 1248 and Arachlor 1260. It's been quite a few years since I've actually worked in this area, so I may not remember all of these, but 1248 and 1260, I think there was also, might have been a 12 20 something, but it actually referred to the this number here, the 12, I think just had to do with the number of carbon atoms that were in here, and the 48 and the 60 referred to the percent chlorine in the molecule. So an Arichlor 1260 is more chlorinated than an Arichlor 1248 would be, for instance. But these things were used, were sold by Monsanto, the chemical company Monsanto, probably up to certainly in the up to the late 70s. And basically, this is a really good dielectric fluid. So this is a material that you can put into an electrical transformer. Those huge transformers that you see out in the field somewhere, most of those things, even the ones that were up on wires used for electrical transmission, those transformers actually had, it acted as a cooling agent and also as an insulator, had these Arichlors in them. And years later, when the transformers were decommissioned, they would be thrown away somewhere, and all the oil, all the Arichlors would leak out, and eventually these things wound up in the water system, because these are very persistent materials. So that's a problem, and it winds up getting, some of this stuff winds up getting into rivers. An example is there's actually a town called, I'm trying to remember the name of the town, but there's a town in, trying to remember, it's called Times Beach, and I think it was in Michigan, if I remember correctly, maybe Missouri, might have been Missouri, but Times Beach was an entire community where there was, I think, perhaps a river running through Times Beach or something like that, and they found a certain level of these Arichlors, of these PCBs, contaminating the soil in the town, and they basically wound up closing down the entire town. I mean, the federal government, the EPA came in, and the federal government kind of cordoned off the area, and everybody that owned real estate in there, I think perhaps the government bought their houses, but they were all forced to move out. And the levels of PCBs were such that I guess the soil could have been treated, the area could have been remediated. To the best of my knowledge, it's never been done. So I think that area is still pretty much cordoned off, and nobody's done anything in that area. But there was also a river, several rivers that have been contaminated with these things. And one of the problems with these kinds of materials and other materials that I'm going to talk about is that they tend to bioaccumulate. So if you look at what the amount that is actually, let's say, dissolved in the water, which is very small because these are lipophilic materials. They're materials that don't like to dissolve in water. They have very low solubilities. But even if you got, let's say, a concentration of 1 part per billion in the water, in fact, animals that would take in this water would wind up bioaccumulating the material because it tends to accumulate in the fatty tissue of living things. So any creatures that are going to take this up, and even bacteria will do this. Some bacteria could in fact concentrate this material maybe 1,000,000-fold in within their structures. So we can go from very, very low concentrations, concentrations that are maybe in the very low parts per trillion concentration, and then if you get 1,000,000-fold concentration, you're in parts per billion, which normally, when we talk about parts per billion, that doesn't seem to be very, very upsetting because it's a very, very small concentration of material. And certainly for PCBs, I don't think anybody worries about parts per billion. But there was an incident that occurred in Japan in the late 1970s, which was something that was really, I don't remember whether anyone went to jail for this, but somebody was selling cooking oil that had been heavily contaminated with PCBs. I mean, it was like somebody took cooking oil and said, well, I don't have enough of this oil. What can I find to mix it with? And they decided to mix it with Arichlors, which already had enormous concentrations of PCBs. You're talking about materials that the concentration would be something in the order of maybe 500,000 parts per million. It's half PCB and half maybe some inert kind of oil. And they were mixing this stuff with cooking oil and selling it to people. And there were literally hundreds of people in Japan who were killed as a result of this. They were poisoned. But these are not the kinds of concentrations of PCBs that we would ever get in the environment. So the question is really, how dangerous are these materials in the waterways, and what kind of properties do they have? Before I get into that, I want to talk about two other classes, related classes of chlorinated hydrocarbons. And one of them are called, one class of compounds are called, let me see if I can find the, it's not a good marker. Let's try this one here. Okay, it's a little bit better. I hope you can see this. One class of compounds are called polychlorinated dibenzofurans. So this molecule is called dibenzofuran. And again, we've got 8 positions in which we can put chlorine atoms. So we can have a variety of different substitution patterns of chlorine atoms. But again, you're going to get a bunch of different congeners. So these are called PC for polychlorinated dibenzofurans, PCDFs. And the other structure that I want to call to your attention, I'm going to erase the PCBs for a moment and put the other structure on top of that. And these compounds, which were of much more concern, are derivatives of this molecule, which is called dioxin. And these compounds are dibenzodioxins. So this is dibenzodioxin. This is, let me just write the name out here. These are polychlorinated dibenzofurans, and the other ones are called polychlorinated. And again, and I'm going to show you the one that seems to be of the greatest concern. Again, there are a whole bunch of different congeners that you can get, but this particular one is called 2,3,7,8 tetrachloro, the 4 chlorines, tetrachloro dibenzo dibenzodioxin. And collectively, these things are called polychlorinated dibenzodioxin, or PCDDs. So you've got PCDFs, PCDDs, and then of course you have what I had put up here originally, the biphenyls. So this compound is a little bit more closely related to a biphenyl. It's a biphenyl in which a chlorine here and a chlorine over here have been replaced by an oxygen atom. So you might have had a chlorine here and a chlorine here, and there are ways in which you can ring close this. You can insert an oxygen in here and make a dibenzofuran out of it, as an example. So a compound like that, if it were treated with sodium hydroxide under the proper conditions, could be converted into this particular compound here, where the chlorines would be here and here and here and here. And these compounds, again, are materials that bioaccumulate. They tend to be magnified when one organism eats them, and then another organism eats that organism. You know, they're going to wind up getting into the fatty tissue and being magnified. So the question is, again, what's the problem? Your book makes a statement here, and it says about dioxins. Let's see if I can find this, because it was the statement that kind of caught my attention. And all right, let's see. It says chlorinated dioxins and furans, 2 other groups of chlorinated hydrocarbons, will also enter the marine environment from land. Pulp mills and waste incinerators are important sources for the chemicals. I don't know. I might take issue with that, because I don't really think, although those materials are formed in those processes, there are other processes whereby these things could actually wind up getting into the water. And this is the statement that I really have a little bit of problem
with. And it says some dioxins are among the most toxic of all chemical pollutants. It says they are carcinogenic and cause birth defects and damage to the immune system in many vertebrates and humans. Furthermore, they show biological magnification. Now, I agree with the statement that they show biological magnification, but when I saw the statement about them being among the most toxic of all chemical pollutants, I wanted to qualify that statement.